From raw seabed to digging the impossible to the world's busiest underwater highway, this is the Chunnel.
Before a single machine could dig, we had to understand the battlefield, the English Channel seabed.
1950s and 80s surveys used seismic profiling to map the layers beneath the waves.
Sound waves penetrate the floor, bouncing back to reveal a geological layer cake.
This is what they were looking for, a core sample from 40 meters down.
3 main layers. The white chalk is too fractured. The gault clay is too soft. They found the Goldilocks layer, the chalk marl. Soft enough to cut, but impermeable to water.
But radar revealed a trap, the Fosse d'Angers, an ancient valley filled with unstable gravel. You can't dig through gravel. The tunnel route had to curve, avoiding the danger zone entirely.
With the route set, the first step wasn't horizontal, it was vertical. Access shafts on both coasts.
At Sangatte, they dug a pit 60 meters deep and 55 meters wide.
A cathedral underground.
2 coasts, 2 different geological nightmares. The UK side was relatively dry. The French side was fractured and wet.
Standard machines would drown. The French side required earth pressure balance TBMs, essentially submarines that could dig.
They didn't just buy these off the shelf. They custom-built 11 mechanical leviathans.
Getting them to the coast was a military-grade logistical operation.
1,200 tons of precision engineering descending into the dark to start the dig. Without GPS underground, this beam of light was their only true north. A deviation of millimeters meant missing the target.
But machines don't run themselves. 13,000 workers descended into the pit. Shifts were long, hot, and loud.
1987. The dig begins. Steel meets stone. The TBM cuts, and a vascular system of conveyor belts pumps the waste out, non-stop.
They didn't dig all 3 abreast. The service tunnel went first, a probe to test the ground for the massive rail tunnels following behind.
As the machine advances, hydraulic arms place precast concrete segments. 7 pieces make a perfect ring.
To lock it in, they inject grout behind the walls, sealing the tunnel from the crushing weight of the sea.
Friction and machinery turned the tunnels into ovens. Temperatures soared to 50 degrees Celsius.
But the sea is patient! A fissure in the rock! Water pressure spikes!
Before paying passengers, they ran massive evacuation drills. The service tunnel had to prove it could be a sanctuary.
Emergency grouting. They're injecting quick-setting resin to freeze the water before it floods the TBM.
The British machines were too big to reverse. The solution? Drive them down and bury them in concrete forever.
The French machines were dismantled, piece by piece, carried back to the surface.
The probe broke through. The alignment was perfect. Britain was no longer an island.
Driving a TBM isn't like driving a car. It's like flying a 747, underground, blind.
To balance the pressure of the sea, the rock paste is extracted by a massive Archimedes screw. It maintains the seal.
The teeth wore down fast. Replacing them meant crawling into the cutter head itself, the most dangerous job on the project.
It's a hungry beast. This rapid feed system supplies a new concrete ring every 20 minutes, non-stop.
The machine leaves a void. Immediately, quick-drying grout is injected to fill the gap, stabilizing the earth instantly.
The commute to work took an hour. A rattling, noisy ride 20 kilometers into the Earth's crust.
Down here, life goes on. Tea breaks, sandwiches, and camaraderie. A brotherhood of the deep.
The tally board. Every soul is counted. You don't go down without moving your tag. You don't leave without moving it back.
In case of decompression sickness or collapse, a full medical bay with hyperbaric chambers was built right into the tunnel. Graham Fagg and Philippe Cosette, the first humans to meet under the sea since the Ice Age.
Communication was a challenge. They even invented a new language down here, Tunnel Franglaise.
But what if a train breaks down? They needed a way to switch tracks underwater. Enter the crossover cavern.
An underground cathedral.
TBMs can only dig circles. To build this cavern, they used road headers, massive tanks with rotating teeth.
Here, the tracks cross in a massive X, a diamond crossing, allowing trains to swap tubes instantly.
And these doors, 80 tons of steel. They can seal off the tunnels in minutes to stop fire spreading.
The service tunnel was just the scout. Following behind were the two main rail.
Before a single train could room, the mud of construction had to be purged. The fit-out began.
This isn't just a hole in the ground, it's a living organism. These massive fans push fresh air 20 kilometers out to sea.
High-speed trains create massive friction heat. Without these cooling pipes carrying chilled water, the tunnel would become a sauna.
And the most critical system of all, 150 kilometers of fire suppression piping. Safety was the obsession.
Next came the power. 25,000 volts.
This isn't normal track. The rails float on rubber boots to absorb vibration. Otherwise, the noise would be deafening.
Overhead, the catenary wires. A perfect copper line strung for 50 kilometers, waiting for the first pantograph.
Trains push air like a piston. Relief ducts every 250 meters allow the pressure to escape, preventing ear popping for passengers.
Finally, the nervous system, signaling. Thousands of sensors to track every train, every second in the dark.
1993, the first test run. Crawling through the dark to ensure every millimeter of clearance was correct.
Smoke test. The ventilation system has to clear this entire section in less than 90 seconds. Watch it go.
Above ground, the terminals were finished. Massive loops of asphalt and steel, ready to feed the beast.
A unique solution, the shuttle, a ferry on wheels. Drive on, park, and 35 minutes later, France.
The first commercial trains rolled out. London to Paris was about to change forever.
160 kilometers per hour, 75 meters below the waves. A 35-minute sprint through the dark.
Engineering triumph, financial disaster, costs ballooned to £9.5 billion. Investors lost everything.
But the tunnel itself? When fire struck in 1996, the concrete held. The engineering survived the ultimate test.
The work didn't end at opening day. Every night, laser-equipped trains scan every inch of the lining for cracks.
This is the brain, the Railway Control Centre. They monitor 400 trains a day, 24/7, 365 days a year.
It's a rolling highway, 1.6 million trucks a year, the artery of European trade. 3 decades later, the concrete rings haven't moved a millimeter. The chalk marl held.
And right here, deep underwater, you can walk from England to France in a single step.
Napoleon's engineer dreamed it. Victorian miners started it. And the 20th century finished it.
Today, 25% of all trade between the UK and Europe flows through these tubes. It is the invisible artery of the economy.
It remains one of the 7 wonders of the modern world. A permanent bond between island and continent.
They said the sea was a wall. The engineers saw a bridge. The Channel Tunnel proved that no barrier is too...
Human ingenuity didn't stop here. The next impossible challenge is already underway. Don't miss the next mega project. Subscribe